Hi, Dikshit here. We want to write our custom programs for Raspberry Pi, be it a user space application or a Linux kernel driver. In last video, we have set up Yocto project for Raspberry Pi without any customization, which means whatever default configuration or packages which are provided by Poki as a reference distribution and Meta Raspberry Pi layer, which is a kind of BSP layer for Raspberry Pi, provides, that will all be there on the generated image. To build our own custom programs, there are two options. Either we can do cross compilation, which means we use Yocto or Yocto generated SDK to build our programs on the Ubuntu host machine, and we copy that compiled programs on the Raspberry Pi and run it. And the second option is we create a Raspberry Pi image using Yocto, which is containing all the tools which is required to build any application or Linux kernel driver on itself, which means native compilation. So in this video we will go ahead and create our custom Yocto image, which is containing all the tools which are required for Raspberry Pi to build its own programs. We are on our Raspberry Pi, which is running a default Yocto image without any customization. To build Linux kernel module locally, we need Linux kernel headers. As you can see, there is no Linux headers as a part of this Yocto image. We will also need compilers like GCC, Mac to build this Linux driver as well as user space applications in our Yocto image. We will start by sourcing the Yocto environment. So the approach we are going to take is we will create our own custom image recipe, which will contains all the packages which we want to make part of our Yocto image, and we will put that image recipe in our custom Yocto meta layer. We will use bitbake layers command to create a meta layer. I am naming it meta noob kernel dev. We will add this layer as a part of bblayers.com using bitbake layers add layer. Now the layer is created, so we will go ahead and try adding our files. So we'll create a directory for putting our image file, recipes core images. For reference, we will copy the image file from Meta Raspberry Pi to our folder and name it as rpi kernel dev image.bb. We'll open the file and try modifying the stuff that we want to add. So this is what rpi test image have, which is based out of core image base. We don't want it, so we remove that. We don't also want to have machine compatibility also, so we'll remove that as well. We'll add some basic information like summary and license. This package group rpi test, right, that is derived from the rpi test image only, so we will keep it for now. Now we will need to inherit a image on top of which we want to make our modifications. So this is a core image, which is a standard bitbake provided image type, so we will inherit that, and whatever package that is part of that core image will be there, and we will add or remove the packages that we want to have as a part of our image as a kernel development image. Now there are three different type of packages we want to add. One is build tools like make, gcc, etc. Second is related to the kernel development like device recompiler, dtc, and the of course linux kernel headers. And there is a other set of tools which are like more of a development tools like vim as editor, file, ldd commands, those things which we use generally to use it while we want to edit something on the machine. Okay, so we will add our image install append here to add the build tools. So this package group core build essentials, this contains all the build tools that we need to build any user space application. So it contains gcc, mac, all kind of compiler stuff that is required to compile any program on the Raspberry Pi. On the second side, we'll again add the packages that we need to do kernel development like linux headers, core utils, and device recompiler. We will also add I2C tools package to use I2C get, I2C detect kind of utilities to work on the I2C bus peripherals. We will add another image install append for the development tools that we want to use like editors, the command line utilities that help us to identify different things on the. We will add all that list of packages that we want to make it as a part of the image, and we will use that on the Raspberry Pi. So we have created the image file with all the packages that we wanted as a part of our image. Now another change which we did was in the local.conf. Now local.conf file is generated every time when you create a bitback environment, basically build directory. So what we will do is now we want to save all those configuration that we do in local.conf, and we want to persist the bblayers.conf that we have used, so we don't need to every time go ahead and do add our layer and make the build. Yocto provides a mechanism to store this local.conf and bblayers.conf configuration as a build conf into a template. So what we will do, we will use this save build conf, and we will use a template within our meta layer to save this configuration. And whenever we initiate or set up a new Yocto environment, we will just need to use this template conf, and all the changes that we have done in local.conf and bblayers.conf will be copied into the build directory. So the current local.conf file is not having any changes, so we will do those changes which we did for Raspberry Pi, like we enabled serial UART. We also made a GPU memory configuration. On top of that, we will also add some other configuration, like we will enable the I2C that we want to use further on the Raspberry Pi. So once we make these changes and save it, and whenever we use this template to set up a Yocto environment, This local.conf from our layer will be copied in the build directory, so all the configuration that we have made here will be in effect. I will demonstrate how this template conf is coming into in effect. Here I am exporting this template conf variable with the path of the template that we created in our layer. After that, when we do source the OE init build environment for Yocto, and we give the build directory as a different directory name, just to see that the configuration is copied into the build directory from our layer. As you can see in the bblayers.conf, our layer is already part of it. Also, the changes that we made in local.conf is also there. Now we will go ahead and build the image that we have created, which is rpy kernel dev image. I have already built this image in a different directory, so we will directly jump to that. As you can see, the output is generated as a WIC file. We will flash this WIC file on the Raspberry Pi SD card, and we will boot our Raspberry Pi with this image. I have already covered how to flash this WIC file on the Raspberry Pi SD card in the previous video. You can check it out. I have flashed that generated WIC image on the Raspberry Pi SD card, and I am booting that Raspberry Pi with that. As you can see, now we have I2C detect as a part of our image. We can also see that Linux header is now added into the image. We will use this Raspberry Pi setup now to do our further experiments with the Linux driver development and tinkering various things on the Linux kernel and device drivers. I have made this layer available on my GitHub. You can check the link in the description. This is the repository name, meta noob kernel dev. You can directly use this layer in your Yocto project to use this customization that we have made. Thank you.